Alright, so in the last video we talked about why it's sufficient just to look at corner points. And in this video what we're going to do is talk about how exactly is the best way to go about doing that. So let's have a different problem now and let's try to maximize 5x plus 7y subject to the constraints 2x plus 3y is less than or equal to 22, 2x plus y is less than or equal to 12, x and y both non-negative. And so, just like before, what we've done is we plotted out the region in question, 2x plus, excuse me, 2x plus 3y less than or equal to 22, 2x plus y less than or equal to 12, x and y non-negative. And here we have uh, f of xy being defined as f of x plus z of y. And this is important because what I want to do then is take a look at our region, take a look at the 4 points that we have here, those 4 corner points, and then figure out what f of xy is at those points. So I'm going to take the first most obvious point here, and that is this point 0, 0. And so what these two commands do here is when I type in a pair of points into this table, it plots that point and it tells me what the f value is at that point. So in the case of 0, 0, it takes 5 times 0 plus 7 times 0 and it tells me that that's 0. And what I need to do now is do that with the other 2 points. And so this is the next point, and it's fairly clear that that is 6, 0. So let me go ahead and pump that in here, 6, 0. And sure enough, that ends up right on the corner here, and that gives me an output of 30, because you get 30 plus 0, which is 30. All right. And now this point here looks to be 5, and this point here looks to be 3.5, I believe. 3.5 for x, 5 for y. But we don't have to guess. I can put in my linear bounds, and I prefer black for this purpose. 2x plus 3y is equal to 22. 2x plus y is equal to 12. And I can see there, yes. That corner point here has to be 3.5 in for x, 5 for y. And so I eyeballed it, and that did look right, but it's good to be sure. Oh, we can also check that my 6 was accurate as well, right? It passes right through this line here. And so finally, I can look at my last corner, 7 and a third. 7 and a third is also 22 thirds. So x value is clearly 0. 22 thirds would give me 51.3 repeating as my output. And so once again, the goal is to maximize f of xy, and the maximum has to occur at one of these 4 corners. So I just ask myself, oh, which one of these is the biggest? And it turns out, hey, this was at 52.5. That's the largest f of xy value, and that occurred at 3.5, 5. So I can say as my solution that maybe f of xy is maximized when x is 3.5 y is 5 with maximum value f of 3.5 comma 5 being just 52.5. And so there we have it. We found the optimal solution. And this Desmos graph, you don't need to build it from scratch. There's a link to it on my website, as well as in the pretext text that's linked to this course. I'll put one in the description of this video as well. All right. Thank you very much. As usual, if you have any questions, please contact me. Thank you.